Dear students, Assalamu alaikum. Keeping in view the prevailing situation all around that has costed a precious and valuable time of the students. So here I am to deliver a bit from my side based on the periodic demands of the students. Today I am going to start with the third chapter of the physics, that's electricity, of the 10th standard. Dear students, before going ahead, we should first of all know what this electricity is. Who gave the concept of electricity? Likewise, who was the founder of the electricity? Which country first used this electricity, and many more things. So I am here to convey you or to introduce you with this very unit of electricity. So first of all, let's begin with the introduction of the very unit. Introduction to the very unit of the electricity. Commonly and in our day-to-day lives, we see that some people call it as electricity and some people used to say simply a term current for this electricity. Now, which one suits best for the business or for the topic? Electricity and current. If on one side they are same and synonyms to each other, but on the other hand, there is a difference. So, going ahead within this video class, I will tell you the difference as well, and I will also inculcate the history of this electricity, how this came into the existence, we may say. So, first of all, introduction of electricity. The very first point regarding this topic is the term electricity. The word electricity is a set of phenomena associated with the presence or movement of the electrons. So, first of all, I may say electricity, it is a set of phenomena, and this set of phenomena, it is associated with the presence or movement of electrons or movement of electric charges. So, what is electricity? The term electricity, it is a set of phenomena which is associated with the presence or the movement of the electric charges. In broader sense, this term electricity, it is simply we can say it involves all the things that are associated with electric charges, or we can say electric current, or its effects, So, the first point which I mentioned here regarding this electricity, in order to make a comparison as well between the electricity and the current. So, first of all, I mentioned here that electricity, the term electricity, it is a set of phenomena which is associated with the presence or movement of electric charges. And it is a broad term. Electricity is a broad term encompassing all the things which are associated with the electric charges, electric current, or its effects. And on the other hand, we usually used to say electricity is also a form of energy. Electricity is a form of energy. And you people know that most of you might be aware with this energy, with this term energy. एनर्जी जो है ये एक ऐसी चीज होती है जिससे कोई काम हो. सो इलेक्ट्रिसिटी से तो आजकल हम देख ही रहे हैं कि कई सारे काम जो हैं, यानी कि लेबर जो है या ह्यूमन एफर्ट जो है वो ये रिड्यूस करवाती है. सो कई सारी मशीनें जो हमारे लिए काम करती हैं, तो वहां पे भी इस एनर्जी का बहुत ही अहम रोल रहता है. सो दैट्स व्हाई आई मेंशन्ड हियर इलेक्ट्रिसिटी इज आल्सो ए फॉर्म ऑफ एनर्जी. एंड इन most familiar words were used to say electricity is a flow of electrons. Flow of electrons. So, form of energy. Electricity is a form of energy. Electricity is the flow of electrons. Electricity के बारे में यूजुअली जो मेन कंसेप्ट है वो कुछ ऐसा है, क्योंकि हम सभी जानते हैं, वी ऑल नो दैट मैटर इज कंपोज्ड ऑफ एटम्स. मैटर इज कंपोज्ड ऑफ एटम्स एंड एटम्स, every atom, within the atom there is a central part which is called nucleus. फर्स्ट ऑफ ऑल आई मेंशन्ड हियर इलेक्ट्रिसिटी के बारे में. इलेक्ट्रिसिटी कैसे आई तो उसके बारे में मैं आपको कंसेप्ट दे रहा हूं कि एक्चुअली दुनिया की सारी चीजें जो मैटर कहलाती है वो बनी है एटम्स की. एटम्स में एक सेंट्रल पार्ट होता है, उसका नाम है न्यूक्लियस. एंड विद इन दिस न्यूक्लियस वी नो दैट विद इन दिस न्यूक्लियस देयर आर पॉजिटिवली चार्ज्ड पार्टिकल्स. Positively charged particles which you call as protons. So positively charged particles called protons, they reside within the nucleus, and in addition to these protons there are uncharged particles as well. Uncharged particles, and those uncharged particles are called as neutrons. So both of these, protons as well as neutrons, they reside within the nucleus and remain fixed within the nucleus. And outside the nucleus there are the negatively charged particles. And those negatively charged particles are termed as electrons. So, students, who surround the nucleus? These are actually the electrons which surround the nucleus from the outer side. So, electrons, protons and neutrons. Protons and neutrons remain fixed within the nucleus. They reside within the nucleus. Now, these are the electrons which revolve around the nucleus, and most importantly, you might be also familiar with the fact that charge of an electron, or we can say the magnitude of the charge of an electron, is always equal to charge of a proton. Charge of a proton. So whatever will be the magnitude of the charge of an electron, it will be equal to the charge of a proton. But the only difference between the two is that one has the charge with the negative sign and the another has a charge, equal charge, but with a positive sign. And what is the magnitude? In case of the proton, we mention it as 1.6 into 10 raised to the power minus 19 coulombs, but positive. And in case of the electron, we mention it as minus 1.6 into 10 raised to the power minus 19 coulombs. Clear? Another point. The number of the electrons outside the nucleus but within the atom, and the number of the protons within the nucleus of an atom, they are always, or usually we can say, they are equal. So I am putting it down here as number of electrons, symbol E with the negative charge. So number of the electrons is usually equal to number of protons carrying the positive charge. So number of electrons is equal to number of protons. So students, that's why when the number of the protons and the electrons within an atom is equal, that means they are balancing each other. Their charge is balancing with each other. And when charge is balancing, so we can say they will cancel each other's effect, and as a result the atom as a whole remains electrically neutral. So when this balancing forces between the electrons and the protons is upset by an external force, so what will happen there? So the balance between the forces of the electrons and the protons, if it is upset by an external force, then there are two possibilities. Either the atom may lose the electrons or the atom may gain the electrons. But when an atom loses electrons, so I am mentioning it here, if an atom mostly loses electrons, so what will happen? This free movement of electrons, this free movement of the electrons, they constitute the electric current. Hope you might have got this or understood this, how current or electricity came into existence. So atom, if it loses electrons, the free movement of the electrons, they constitute the electric current, and this electric current is the electricity here. Now moving to the another point, I have here such things that will fascinate you entirely. So let us begin with the concept of electricity. Who gave the concept of electricity? So there are so many concepts justifying the existence of the electricity, but the most valued one which I remember is an Italian physicist namely Alessandro Volta. Italian physicist, Alessandro Volta discovered that if certain chemical reactions are carried out in such a manner, then they could produce electric charge or electric current or electric charge. And in the year 1800, Alessandro Volta constructed a voltaic cell. He constructed a voltaic cell, or you can say voltaic pile. Now, most of you might be thinking what this voltaic pile is. Let me tell you, voltaic pile is an early electric battery. So, what did Alessandro Volta did? In the year 1800, he constructed a voltaic pile. Voltaic pile is an early electric battery that produced a steady electric current. So he was the first person. Alessandro Volta was the first person to create steady flow of the electric charges, electric current, or you can say electric charge. So this was the first thing which I mentioned here, supporting or justifying the concept of the electricity. I mentioned this valued or this pioneer physicists, namely Alessandro Volta. Moving to the another point, let me tell you in the synopsis manner about the founder of the electricity. Who is given the credit of being a founder of electricity? Not a single person, not a single physicist. Numerous number of the physicists come into the list, but the one I'm going to mention here, that is Benjamin Franklin. Benjamin Franklin, most people gave credit to Benjamin Franklin for discovering electricity. Benjamin Franklin had a greatest minds or scientific minds of his time. He was interested in many areas or fields of the science, discovered many things, invented many things, including the bifocal glasses. Benjamin Franklin was the one who carried out his experiments in America in the 18th century and successfully he also gave the two kinds of the electric charges or electric currents. Two kinds of electric charges. This Benjamin Franklin. So Benjamin Franklin के repeated और continuous experiments की बदौलत से ही the principles of the electricity become understood. And luckily, fortunately, in the mid 18th century, everyone's life was changed with the discovery of this electricity. So don't forget this Benjamin Franklin, who has contributed a lot in providing us this public electricity supply. So moving ahead, I am going to mention here what was the first form of the electricity that was used. First form of electricity. First form of electricity. First form. First form of electricity. Dear students, I am just delivering you the very introduction of this chapter. I have not touched a single topic of this chapter yet now. So, once the introduction will be over, you will be knowing all these points, and after that we will move to our first subtopic, starting from the electric charges, importance of the electricity. So my introduction is not over yet. Here I am with the point, first form of electricity. What was the first form of the electricity? So let me tell you that Edison's light bulb, Edison's light bulb is the first application of electricity to the modern life. He worked initially with J.P. Morgan and his privileged customers of New York City in 1880. And lit their homes, pairing the new incandescent bulbs with the small generators. So this was the first form of the electricity. So I'm going to erase this now because still some points are to be discussed with you. Let me tell you now, the first country that used the electricity, first